In this video, we're going to be looking at the next step in understanding Lewis structures. As I mentioned in class, I sort of think of the ones that we've done up to this point as being level 1 in drawing Lewis structures. Our next level is adding the idea of resonance. Now, this won't apply to all Lewis structures, but it applies to quite a few of them, and the idea of it is very important. So we're going to cover that in this video and possibly one more video, depending on how long it takes to go through this. The best way to think about resonance is to do an example. So we're going to look at the molecule ozone. We all know ozone is a very important molecule in the atmosphere. It's actually quite relevant to some of the molecules that I study in my research. I don't study ozone itself, but I study molecules that react with ozone. And we all appreciate having ozone up in the stratosphere in the very high levels of the atmosphere to protect us from ultraviolet radiation. So ozone is a really important molecule. And the formula for ozone is O3, which is, and the question, of course, that we're asking now is, what's the structure of ozone? What is its Lewis structure look like? Okay, so let's go ahead and follow our rules. So we have 6 electrons per oxygen, so that means we get a total of 18 electrons in our Lewis structure here. We need a central atom. They're all oxygen, so let's pick one of our oxygens and bond the other two on either side. All right, so that's our basic structure here for ozone. Now we need to add lone pairs to our outer atoms, so we can go ahead and do that. And you can either draw 2 dots or lines. I find the lines a little bit quicker to draw, so I'll often write it as lines, but your textbook tends to use 2 dots. So just when you see a line like this, that is the same as 2 dots for lone pairs. Okay, so do we have enough electrons? 2, 4, 6, 8, 10, 12, 14, 16. We need 2 more electrons, so we'll put that on the central atom. And now we'll check, does everything have an octet? All right, so the outer oxygens do, we made sure they did, but our inner oxygen does not. Okay, so we're going to need to share electrons from the outer atoms, form a double bond to get enough electrons for the central oxygen. Now, we could do this either sharing from the left oxygen or the right oxygen. Which one's right? Well, both of them give a correct structure. So our options are, we could have the version where the left side forms a double bond. We still have the lone pair on the central atom, and the right side has a single bond, and this gives an octet for everything. If you count all the electrons, you should see that there are 8 electrons when we consider the bonds. But we can write an equivalent structure where the double bond goes the other way. And the question is, which of these is right? Now, we can look at experimental evidence of how long these bonds are. One thing about single and double bonds that we'll discuss later in the chapter is that single bonds tend to be longer than double bonds because there are fewer electrons holding the atoms together. The more electrons they are, the closer the atoms will be to each other. So if one of these or the other is right, we would see one bond being longer or shorter than the other. But what we actually observe is that the 2 bonds are of equal length. And so what this implies is what we actually have is sort of a mix of these two, and this is what we call resonance. So we have a mix between our double bond on the left version and our double bond on the right version. Both of them are valid Lewis structures and behave essentially the same. And so one way to represent this is that what we actually have is not really a double bond on one side and a single bond on the other, but we actually have sort of a 1.5 bond on both sides. I'm not going to draw the lone pairs here because it gets a little confusing about where are all the lone pairs when you're only sharing half of the electrons. So the real structure is somewhere in the middle, in between having just a single bond and just a double bond. Think about it as like a 1.5 bond. And so these resonance structures, so these are known as resonance structures, by looking at them together, the combination of them will, if we sort of average them out, that will help us understand what's actually going on with the electrons. One thing to remember about Lewis structures is that they're a useful model for understanding bonding, but that they're only a model. They don't necessarily give us the full picture of everything that's going on. And resonance is one way we can make sense of the fact that we can draw multiple Lewis structures for a single compound. All right, so that is the introduction to resonance. We'll do another example in the next video.